Before I get started, just can everyone hear me just fine? Okay. Just want to thank you guys for the opportunity to come and share with you MnDOT's work, and specifically our work at the MnROAD research facility, where I am a research project engineer. So brief overview of what I'm going to be talking about today. First, starting off, why does MnDOT do research? Then what is the MnROAD facility? Kind of who are our partners? Who do we work with? And then I'll got a couple slides on just pavement engineering 101, come to the challenges that we face as pavement engineers. And then my favorite part, highlighting some of the projects, and then how students especially can become involved, or anyone that is interested can be involved with us. So starting off, why DOT research? Basically, I have this slide in here just to show MnDOT is responsible for over 10% of the roads, or about 10% of the roads in the state. It's a combination of bituminous, which is asphalt, our asphalt over concrete, and then concrete roads as well. But the big reason why is because when this last fiscal year, over $3 billion in road construction and maintenance. So our goal, especially at MnROAD and in research in general, is making our pavements last longer and cost less financially and cost less to the environment. So now getting into the MnROAD research facility, how many people have driven I-94 from the cities to St. Cloud? Okay, thank you all of you for providing free traffic to our research facility. The accelerated pavement testing facilities like MnROAD are pretty unique and rare. The only one that's even comparable in scale is in Auburn, Alabama, where they pay truck drivers to drive and traffic their trucks. Here at MnROAD, we use the general public and the traveling public to traffic our roads. So as you can see, we have the existing I-94, which was built in the early 70s. It's a jointed concrete pavement. And then parallel along that, we have the MnROAD, what we call the MnROAD main line. But if you've driven this, you've seen the big overhead gantry lights. Traffic diverts you to the, or you're diverted to the right. And then you'll see the pavement changes every 500 feet. It looks like a quilt. And those are each individual test sections where we're trying different pavement materials, different structures. I'll get into some of the sensors and stuff that we have going on in there as well. But next time you drive through, now you'll know what you're doing, and you can even, there's an AM radio band that you can turn to and entertain your whole family as you're driving through, in case you forget some of the facts I'm presenting today. And then we also have this loop, which is a little further inside. There's actually, it's divided, there's a fence there. And this is a closed loop facility where we have a semi-truck driver who his sole job is to drive circles around this facility 5 days a week, 8 hours a day. He shoots for 80 laps on this 2.5 mile loop. And we have the same kind of setup here where we have 500-foot test sections. But the purpose here is more to simulate a low volume road. So we have thinner pavement structures, less base work, less preparation, some more exotic materials where this, for example, like this 2017, we brought in a bunch of clay, and the goal of the project was to simulate a late construction season event where we had a wet, sticky clay that we could not pave over with typical paving methods. So it was a large stone base experiment. So we ended up bringing in softball size stone, and one of the sections was 9 inches of this large stone base, and the other section was 18 inches. And we learned within half a day trying to place this 9-inch section that we needed, that wasn't going to work. We needed a reinforcing grid to be able to do that. So that's the kind of stuff that we're able to do at MnROAD at this facility, where we can take risks that we couldn't normally do, and we can simulate real world challenges but more in a controlled environment where we're not under the immediate pressure of the general public and traffic trying to get the road open. A little bit of history. MnROAD was initiated in the early 90s and has 23 years of customer service. Like I alluded to earlier, it is an internationally recognized facility. For those of you who have not been there, I would encourage everyone to go up, whether you're a student or a practicing engineer. I have my email at the end. You can take a card, but we're always willing to come and show you because as taxpayers in Minnesota, you have helped support this research effort, and it is truly a treasure in your own backyard. We have asphalt, Portland cement concrete. We're currently in the third phase of MnROAD, and I'll get into it more later, but we're expanding with our partnerships as well. We still do MnDOT only research. We have a couple sections that are internally funded with just MnDOT, but we also have partnerships with other upper Midwest states. We have partnerships with one of the research facilities in Alabama, federal highway, and then private industry partners as well. So there are currently over 35 ongoing research studies. So we have test sections combined into research studies with 141 unique test sections. I-94 mainline, we have 12 ongoing studies. And then we also, in 2017, we went back to the original concrete pavement, which we call Old Westbound, but the original I-94 concrete, and we started placing research sections on there. We don't get as much traffic as we do on our main line because we have traffic one or the other, and we try to keep traffic about 80% of the time on the main line and only switch it back to the old original construction when we need to do our testing or construction type activities. And then the low volume road, there's 19 studies, 50 different test sections. I list the Minnesota Local Road Research Board here. They're one of our major sponsors and players with MnROAD and supporters, even from the early 90s. They're one of the reasons MnROAD exists today, and we still try to keep that relationship and support local county road research that a lot of us drive on our way home every day, or most people drive on our way home. And then in 2016, we started some off-site experiments, which are still under the MnROAD umbrella, and they're near Malacca. But we have on 169, and I'll talk more about these later, we have some pavement preservation experiments on US 169 as well as County Road. It's in Pease, Minnesota, for those of you that are familiar with that area. So our traffic loading, it is live interstate heavy truck traffic, about 13% truck traffic on the interstate. I would argue it's a little more than that just from looking out the window and seeing the trucks go by all afternoon and all day. And then our low volume road, we have a 5-axle typical tractor trailer that is loaded to the legal limit, and it, like I said, he drives in circles 80 laps a day. So operations support, which is the team that I am a part of, we're actually based in the Office of Materials and Road Research within MnDOT out of Maplewood. And then we are back and forth between the two sites. Some of us are actually based up in MnROAD, which is technically in Monticello, Minnesota. But our job is to do research and development, partnerships, construction, traffic loading, performance monitoring. So we build these test sections and then we monitor the performance. When I say monitoring performance, we are literally, I was out there yesterday counting cracks and making crack maps. We do everything from visual distress surveys like those crack maps to we have automated equipment that uses 3D cameras to do the same crack mapping that our pavement management uses on a network level. And then we're measuring RUT, IRI, the structural integrity with falling weight deflectometer. And then we have an array of environmental and dynamic sensors. Basically, our environmental sensors are monitoring how the pavement and the pavement structure is changing due to the environment. And then our dynamic sensors, how are they changing under traffic? We use our truck, our semi-trailer, which we have known weights on each axle, and then we measure the pavement response from that known axle weight. And all of this goes into the MnROAD database, which is available to anybody. It's online, but it's accessed from researchers around the world. There's people from Alaska to Florida and everywhere in between who have done a thesis off of MnROAD data and have never actually been to Minnesota. I'm sure internationally as well, other places use MnROAD data, but just for an example, within the US university system, our database is used frequently. Winter operations, we kind of are starting to dial it back for the winter. We're filling in our last few crack maps and that kind of stuff before everything is completely frozen. But we do, so our low volume road, it is treated like a county road where depending on the truck driver and depending on how much snow, he might not even plow. He might just take the truck and go slow for a couple laps and let the snow kind of push out. Whereas the Interstate 94, that's actually taken care of by MnDOT District 3 maintenance out of Monticello. There's a truck station that we work closely with, and they're actually the ones responsible for maintaining that. And they have a bare pavement policy, so after there's a snow event, they get all the way down to bare pavement just as if there was not a cold weather event. Benefits of MnROAD. We've done lots of studies showing cost-benefit ratio depending on the specific experiments, and I'll talk a little bit more about these experiments later. But huge benefits, 9-to-1, 5-to-1, and I'll get into details of these projects further in my presentation. So now to the partnership section. So who are we currently working with? So in 2016, the National Road Research Alliance was initiated, and how this kind of got initiated was MnROAD had $2 million in construction money. We had test sections, but we wanted to reach out to other states and get more national involvement. So what we've done is created the National Road Research Alliance. We currently have North Dakota just joined within the last month, so they're not pictured in there, but they're counted in my 7. But we currently have states, industry sponsors, as well as academic sponsors that participate in this. And basically, we have different teams in whether it's a flexible team, a rigid team, a soils team that focuses on developing research projects that have a national impact and a national interest within that specific area. So here's a quick snapshot of the latest list of the sponsors, but you can see there's everything from DOTs to universities to big companies like 3M and Cargill, AET, some consultants, contractors, pretty much anybody that has an interest in the pavement industry has a seat at the table. If you're willing to participate in the meetings and show up, you have a seat at the table and your voice can be heard. Another research partnership that we currently have is with Auburn University in Alabama, and we have a pavement preservation research partnership with them. So those sections in Malacca that I mentioned, they are sister sections, I'll call them, to pavement sections that they have in Auburn, Alabama, where we have the same treatments in 2 different climates, and we have them, just like we have in Mille Lacs County, we have on a U.S. highway, so we have them on US 169 as well as a county road. In Alabama, they have them on a U.S. highway and then a small county road as well. And we're comparing how these treatments perform in different climates. We're actually able to get the same contractor to construct, and we use similar mixed designs but with local materials. So Minnesota, the sections we built were with Minnesota materials, but we were actually able to use the same contractor, so we tried to eliminate the contractor being a variable. So far, some of the big takeaways that aren't surprising, as Minnesotans, you guys all know, thermal cracks make our pavements nice and rough. They don't have thermal cracks in Alabama, so their ride values are a lot lower just because of the thermal cracks, and a lot of the preservation treatments, they're not going to fix a structural thermal crack that goes through your pavement. Another chip seals, that kind of stuff. Our chip seals get beat up by snowplows. They don't have snowplows. Their chip seals tend to stay a lot longer, but they do see more kind of bleeding and flushing with some of their heavier chip seal applications that we don't see here in Minnesota. So this slide more for students or those that aren't as familiar with pavements, but you'll see me throughout this slide, I'll say rigid or PCC, but a rigid pavement is basically, it's a concrete pavement, but the way that functions is basically a slab, and we are designing the base just to support that slab, mainly the base of that in a concrete pavement. Our base is mainly there to support our construction traffic, and then so our interaction is the slab itself that's moving, whereas our flexible pavements do just that. It's an asphalt pavement or bituminous hot mix, you'll also hear it called, but the pavement, a wheel comes over and it actually bends and flexes underneath the wheel load. And then we have our composite pavements, which are concrete over asphalt or asphalt over concrete. And then, yeah, so now looking at specific distresses that we're trying to address and fix at MnROAD. So in an asphalt pavement, we've got our top-down cracking, our rutting, which I'm sure everybody has seen at intersections, that kind of stuff. Rutting, top-down cracking are traffic-related distresses, so you'll see them occurring along the wheel path. And then you have those transverse cracking or low-temperature cracking, as it's also referred to. Basically, as the temperatures get really cold, the asphalt binder contracts, and then it snaps at the weakest point. It's just a stress relief, and then we get these cracks that are more or less regularly spaced within our asphalt pavements. Similar yet different challenges with our concrete pavements. So concrete pavements, your joints are your weakest spot where you have water being able to come in. You have the faulting that occurs at joints where one panel will be, your panels end up being tilted like this, where you have one like this and the next one like that, because the truck hits the front of it and it pushes it down a little bit and it raises on the next end. We refer to that as faulting, and you can feel it and hear it as you drive down old concrete pavements. Now getting into MnROAD research projects, and this slide is my favorite slide of everything that I'm going to talk about because it's what I get to work with the most, but that's the instrumentation that we have at MnROAD. But what I have here is just a schematic of our sensors. So we have PGs, which are earthen pressure cells, but basically a pressure plate, and then the LEs and the TEs are longitudinal strain gauges and then transverse strain gauges. So we're measuring, those are placed at the bottom of the pavement or at the bottom of the asphalt. So we're measuring how much our pavement bends under a wheel load in each direction and then how much pressure that wheel load was applying. So truck drives over, we end up getting a response like this. It's a little inverted, the truck should be facing the other way, but we get nice clean responses most of the time where you can see, okay, there's our steer axle, there's our 2 tandems from the truck, and then our 2 tandems from the trailer. And then from that, we're able to compare with our design and design software and see, okay, this was designed for a anticipated microstrain of 100, and we're getting a microstrain of 150, we're going to have fatigue failures faster because it's bending more than we're designing. So that's the kind of information that we gain out of this pavement instrumentation. Other instrumentation that we have moisture gauges within the base and subgrades. We have temperature probes throughout the depth, so we can monitor how the temperature profile within the pavement itself, as well as within the underlying base and subgrade. Concrete gauges, we have strain gauges in concrete as well. We have two different types, one that measures a truck load, and then we also have one that measures the environmental load. So that one is measuring how much is it shrinking and expanding just due to the change in temperature. We also have a new sensor that we developed now that we place between concrete joints, and it's measuring how much that joint opens and closes, and we're able to pick up the daily cycle of the joint opening and closing, as well as yearly or seasonal fluctuation as well. So specific projects, and I've only been working at MnROAD for less than 2 years now, about 1.5 years. So a lot of these I wasn't immediately involved with, so I'll kind of skip through them a little bit quicker. But some of the big highlights that we've learned over the last 20 years, and some of these, like importance of drainage, yeah, it sounds intuitive, but what MnROAD is able to do is to be able to get data and be able to prove, yes, drainage is important. We have a section here that has drainage, this section doesn't. We see failure faster in the section without drainage, and then we're able to cut a trench, dig into it, and see what water in the base or subgrade is actually doing to our pavements. So along the same lines as importance of drainage, importance of sealing, both concrete and asphalt, crack sealing or joint sealing. We have lots of side-by-side type comparisons. I'll let you guys read that one. Optimal timing of preventative maintenance. So this is one of the things that, as a lot of you guys know, and those of you that are still in school will soon learn, is a lot of our infrastructure has already been built, and the challenge that we're going to be facing as engineers is maintaining that infrastructure, and how we're going to be able to keep our current investments and make them last as long as possible, but also keep innovating and bringing in new materials and not keep doing the same thing, but making improvements to make the infrastructure better and do it on a shrinking budget. So we've done a lot of chip seals at MnROAD, actually on the interstate main line. Those of you that are familiar with chip seals, it's typically used as a lower volume type treatment. We've done it at MnROAD as well, so with interstate traffic going 70 miles an hour, and when done properly, they can perform well and provide a nice resurfacing treatment. So microsurfacing is another thing that we've used at MnROAD, kind of this preservation type, but a microsurfacing it's applied in a slurry, and it is a combination of an asphalt, but it has a little bit of cement in it. It's got a real fine aggregate in there, and it ends up with a nice smooth black surface. Some of our work in Malacca has shown that it can be a little bit brittle on some of the applications, where we're seeing cracks reflect through a little bit quicker than we would with a typical asphalt layer. One of the big cost-benefit savings that we've realized from the work done at MnROAD was the seasonal load limits. This came out of work done at MnROAD, where we have our temperature sensors throughout the pavement structure. You can see this one, you see this flat line down here, that flat blue bottom. That's the frost depth, and it did not bottom out at that. It just means our lowest sensor was at 72 inches I forget. Okay, so this is in Otter Tail, Minnesota. But what we're able to use this to determine when we're going to be restricting truck traffic or heavy vehicles. For those of you that aren't familiar with seasonal load limits, the issue is where we have this area in red here, where we have a real frozen subgrade. Our majority of our structure is frozen in the spring months, and then we're coming out of that, and it's thawing from the surface down, so you get this soft, squishy, mushy layer on top of your frozen layer, underneath your more rigid pavement layer, and then all your water is just trapped right there. So that's why when you see seasonal load restrictions, that's what we're trying to prevent, is heavy vehicles damaging our pavement in its softest point. And we do this at MnDOT. It's separated out by zones. We have sensors in each of these zones, a couple locations in each of these zones where we're monitoring the frost depth in each of these. That's why every year the seasonal load restrictions, the timing of it changes a little bit. One of the more unique studies that we've done at MnROAD was an implements of husbandry, or basically how does farm equipment damage a typical county road. So in this study, we paved a special road or a special section, both concrete and asphalt, and brought in all sorts of, there's a list on here, but different farm equipment, husbandry equipment, and so we had sensors in the pavements, different bases, different subgrades, and how was the pavement responding under these farm equipment type vehicles, so that we see on our county roads. In pavements and in our civil engineering industry in general, we're doing a lot more recycling than we ever have. What this slide is one of the projects that we're doing is on full depth reclamation, basically where we're taking the existing pavement structure, we're coming through, we're grinding it all up, we're adding a little bit of stabilizing, whether it's cement or asphalt, and then we're paving a new road over the top of it, but utilizing the materials in place. We're eliminating truck traffic, we're eliminating the need to remove old material, and then we're able to get a nice clean surface and base that we can pave over with a lower thickness pavement layer than we typically would. Concrete innovations. There's been a lot of work optimizing thickness, a lot of work with thin pavement designs, smaller sized panels, bonded and unbonded concrete over asphalt. The design manual for bonded concrete over asphalt was developed based off of MnROAD research. And that's this slide, which is our white topping, which concrete folks love, covering up the asphalt roads and putting a nice white concrete road down. And what we're able to provide at MnROAD is the ability to push the limit. So right now, 2017, we built a 3-inch thick concrete pavement, and we replaced half of that a couple months ago, just because it started to rubbleize under that semi-trailer that I showed. But we also built a 4-inch thick right next to it, and it's got fiber in it, and the 4-inch thick is performing just fine, and it's a relatively soft base that it's on. But 3-inch thick, it's like, okay, we learned the limit. We need to stay away from 3-inch thick. There's sidewalks that are thicker than that. So we're able to quickly learn and get a result relatively quickly. Like I mentioned with the sensors, there is a lot of our data, a lot of what we're gathering at MnROAD is directly input into design manuals and methodologies, whether it's developing new design guides or calibrating existing design software. One of the more unique things is we have all of this emerging technology that we're able to use at MnROAD. whether it's asphalt rolling patterns or infrared technology. We've got 3 or 4 researchers in our office that are working with ground penetrating radar and rolling density meters, but trying to bring new technology into pavement industry. So as well as training contractors, we're also working with other states, working with Federal Highway, trying to bring the industry on board and get this technology that's out there from academia implemented into everyday pavement construction. I'm going to skip over culverts. I'm going to skip over porous pavements, just in the interest of time. Like I mentioned, we do a lot of partnerships. This partnership we just did actually a month ago. But Cargill has a new rejuvenator product, which allows us to use more recycled asphalt pavement or reclaimed asphalt pavement in our asphalt mixes. And this is supposed to take the old pavement that has been on the road for 20 years. It's been beat by the sun, it's brittle, and this product is supposed to rejuvenate it, which allows us to put more of it into our mixes, use less virgin materials, and not have large amounts of stockpiled old asphalt. So I mentioned these sections a lot already, but it's off of US 169. This is in Mille Lacs County, and then County Road 8. For those of you that are familiar with Pease, Minnesota, so this is on the east side of 169 on County Road 8 is our test sections. But if you drive 169, you'll see the same change in pavements every 500 feet. Looks a little different color. But on the west side is my favorite part of going up there and doing collection and looking at these pavement sections, and that's the Pease Cafe. So it's a good place to stop if you're ever looking for a good home-cooked meal and you're up that way. Anyway, so we have a lot of, I'm not a paid advertiser for the Pease Cafe, but I do endorse the Pease Cafe. We have a lot of different treatments up there. There's 30 different pavement sections in each of those sites. And then we have 2 different levels of traffic. And what we're doing with those sites is, so we also have control or untreated sections in there, but we're trying to build points along this curve so we're able to let us know when's the best time to do maintenance and what will extend our life the longest, and what is the benefit of that. How much are we saving by doing a treatment when we're still in this green zone, as opposed to waiting until it's really bad and in the red zone where we can't fix it, or even where it's in between in the yellow, where we're really not getting that benefit for our dollar as if we did it a couple years earlier. So at MnROAD, we're open to all sorts of other non-pavement type research. 3M has an experiment where they're looking at signage and vehicles interacting with the signs, and vehicles being able to read the signs and get information from the signs that isn't visible to the human driver. Another partnership that initiative that we did with Mike Kronzer's office, and this is my transition to Mike Kronzer, is last winter we had an autonomous vehicle and did autonomous vehicle testing at MnROAD, and Mike, I'm sure we'll talk a lot more about this, but the idea was, how do these autonomous vehicles perform in a winter climate? So we were able to use our low volume road facility where we could safely put water on the pavement in January and make ice for the autonomous vehicle to travel over. We brought in a snow blowing machine. How did the autonomous vehicle interact with snow? The type of thing that isn't typically done where a lot of autonomous vehicle research is done in warmer climates, and MnDOT was able to do because of the MnROAD facility. So this slide is especially for students, but for everybody here, we're always, MnDOT and especially MnROAD is always looking for good, hardworking students. This spring we'll be hiring interns for the next summer, or student workers for the next summer. And then MnDOT has a really good grad rotation engineer program where you're exposed to different sections within MnDOT, and you can kind of find your niche by seeing it all over a course of 2 years. Anybody, like I mentioned, is welcome to come up, contact us. We'll give you a tour, whether it's you driving up north to your cabin and you want to stop by one Friday and talk pavements for an hour or so, just feel free to reach out. But I'd really encourage the students to put together a group and come up for a field trip and learn about MnROAD and the opportunities that you have in your backyard. So with that, any questions? Yeah.
So I-94 is slated to be expanded to 3 lanes in each direction. What does that mean for?
So MnROAD will still exist. We're still working out the logistics of it. Some of the options we're considering is expanding to 3 lanes and then diverting trucks only onto the MnROAD facility. That one I think is probably leading. If we can find funding, we may still do 3 lanes of the MnROAD facility as well, but that kind of just logistically, traffic maneuvering 3 lanes of traffic is a lot more difficult than moving 2. So we're still trying to work through that. But yeah, you're right, it's coming and it's needed, so. Yeah.
Do you construct test sections yourself, or do you have contractors?
We have contractors do it, but we are on site monitoring the construction, documenting construction, overseeing it. A lot of times we'll work closely with MnDOT's regular inspectors, and then we'll have our own research staff there as well, because we have our sensors in the pavements as well. We're taking extra samples for research. So we work very closely with our MnDOT inspection team as well as with the contractors to make sure that our sensors don't get ran over, for example, or that kind of stuff. So it's a pretty unique kind of dynamic that goes on there. But no, we are not the construction or the maintenance stuff as well. Along those same lines, a lot of our maintenance is done by District 3. There's a truck station in Monticello, and they work with us, monitor and help us monitor and tell us what went down, that kind of stuff. And we try to stay ahead of them so they don't just come through and repair it because they're getting phone calls about it. But we try to work with them and say, hey, we've got this issue that we know is going to be coming up, that kind of thing. Good question.
The low volume loop, is that a 12-foot wide loop, or is it 2 lanes?
2 lanes. Good point. I kind of skipped over that. So the inside lane is where the truck travels. The outside lane is left for environmental monitoring. So we pave both of them with the same section or whatever material is in that. They're paved exactly the same, but the outside lane is just for assessing impacts from the environment, whereas the inside lane is what actually gets traffic. So it gives us a nice additional control to compare to.
Building a test section, the truck is stopped for that time period?
Yep. Yeah, so our truck driver turns into our skid steer operator and helps with construction, and especially with a lot of the sensors and stuff, we need to have a skid steer on site to drill in to install our deep sensors or that kind of stuff. So.
Is there different type of test sections on that one too that the truck just runs around all the time? Or
Yep.
is it all one type?
It's all different types. That's where like that 3-inch concrete pavement, that's where that was located. So on that low volume road that the truck driver drives around, the intent is more thinner type, less expensive type treatments, trying to replicate more of the local county road, local street kind of level. That's one where we work closely with our local road research board as far as what sections are going to go there. There's sections on there that were solely sponsored by them. Yeah.
Have you considered actually having overlaid
Yep. We have considered that, and we actually used to have an overloaded tractor trailer that drove the outside lane in the first 10 years of MnROAD, and we've since switched it to having that be an environmental lane. But no, we want to stay realistic with and can be able to compare to what we're using as design inputs for design software and calibrating design. So I think that decision was made before me, but that's why we've gone to, we call it accelerated pavement testing, but we don't use heavy loads. Yep. Yeah.
So I know I was reading in Europe they were doing some testing on the solar panel roads and that kind of thing. Is there any future considerations that you guys have for using renewable energy and that kind of thing?
Yeah, so we are always open to anyone that has an idea and wants to come and sponsor a test section. If you have an extra $1 million and you have an idea and you want 500 feet of test section, we can find a pavement, whether it's on our main line or on our low volume road. We have a list of stuff that needs to be replaced in the next couple years. But as far as MnDOT led initiatives, not speaking, so in my personal opinion, a lot of those technologies I don't think are cost effective, especially for a DOT at this point. But when they're ready and when someone has an idea, we're always willing to try new things, and this is the perfect place for it. So even stuff like the Cargill sections or that kind of thing, if someone wants to try something, they can sponsor a section and build it. Whether you're from industry or from another agency. Anything else? All right, like I said, I'll be here. Feel free to talk to me, get a card, or contact me. We'd love to have everyone up, and I'll turn it over to Mike. Yes, you do.